Another difference between polynomial equation and polynomial inequality is that the solution of polynomial equation is finite. I mean, it could be countable. It depends on the high exponent of polynomial function. So it could be 3 or 4, 5, 6 solution. However, the solution of polynomial inequality is infinite. It has so many solutions, and that's why we have to use interval notation to express the solution of polynomial inequality. Solution of polynomial inequality graphically is nothing but the interval or part of the domain where polynomial function graph above or below the x-axis. If it's above the x-axis, it's positive. If it's below the x-axis, the polynomial is less than 0. Okay. Now, a very basic polynomial inequality we already learned in college algebra is quadratic polynomial. So let's first go take a look at that example, quadratic polynomial inequality again. Then we're going to go through the higher exponent polynomial inequality. Okay. So example number 1. So I give you this quadratic, and I put this greater than 0. A quadratic is just a very typical example of polynomial function, and I put it greater than 0. It means that this is a polynomial inequality. And generally, a way to solve polynomial inequality is we find the interval where the function above or the function below, right? And that's why we have to use something called psi table. The psi table will tell you what part of the domain is positive and what part of the domain is negative. But before we can use the psi table, you have to factor a polynomial. We have to find the zero where the graph intersects the x-axis of this quadratic. Okay. So let's factor them first. Okay. Then we're gonna set up the number line, the table. So you always start from negative to positive infinity, and on this number line you're gonna put on the 0. Okay, make sure you put in order. So negative 2 must be on the left hand side of 3, right? And you see that excuse me, I have very bad allergy, so you see that after I put the 0, negative 2 and 3 on the number line, it divides the whole number line into 3 parts. Okay, into 3 parts, and we have to check what part is positive, what part is negative by pick up value inside each part and plug into the original inequality, the original one. Okay, the original polynomial, to see if it's positive or negative. For example, over here I pick 4. You can pick anything as long as it's greater than 3. You can pick 4 and you plug it in. You see, obviously this is positive. Right, you go 4, you plug it in for 16 minus 4, 12 minus 6 is positive. Okay, 12 minus 6 is 6, so it's positive. And you do the same, you plug the value between negative 2 and 3. So I plug 0, so it's less than negative 2. For example, negative 3, so give you positive. Okay. So after you got the sign, so this is called a sign table. Okay, so after you got the sign already, and you have to see it, originally we need something greater than or equal to 0. Something greater than or equal to 0. It means we're gonna take the left hand part and the right hand part right here. We don't want to take the part that be negative, right? So this is the one we're gonna take. This is the one we're gonna take. So if your solution will be what will be from negative infinity to negative 2, and remember this is the equal sign, so you have to use the bracket at the endpoint, a union with 3. This is equal sign, so you have to use bracket at the endpoint. Of course you never use bracket for infinity. Here you go. So I just saw the very basic polynomial inequality, the quadratic one. Okay, what if I have something harder than this? Something has more factor. I mean, if it is in factor form already, that would be very easy, right? Because you don't have to factor. But if it's not, then you have to factor. For example, I have something like this. I have 2x minus 2 square times x plus 3 times x minus 5 raised to the third power, and I want this less than 0. Okay, and I want to solve this. Question is this polynomial? Yes, it is. Is this polynomial inequality? Yes, it is, because it's less than. Okay, so again we have to find a 0. So you have to find a 0. You're gonna put those 0 because this is in factor form already, so we don't have to factor anymore. So you're gonna put on a 0. So the 0 will be negative 3, right? 2 and 5. So we have totally 3 0. Okay, and you're gonna do like this. So this is because over here this one is has 3 zeros, so it's divided number line into 4 parts. Okay, into 4 parts, and we're gonna check the sign for each part by plugging the value. For example, you want to plug in the values for this part. You want to plug 6, right? You want to plug 6 into that, so it's give you positive, right? Plug into the original one, right? Then you want to plug 3, right? You plug 3 or 4, it's up to you. So 3, so give you what? It could be negative, right? And over here you want to plug 1 or 0, right? You want to plug 0, so it should be negative, right? And you want to plug the value less than negative 3, so for the negative 4, then you're gonna have a positive. Okay. And what we want something less than. It means that we're gonna take this. We're gonna take that. Okay, because it's less than. But are we allowed to take number 2? Just think about that. We take those things, but we're not allowed to take number 2 because at 2, look at that, at 2, right? At 2, when you plug it in, it gives you 0. So at 2, you plug it in, it gives you 0. Alright, 2 over here 0, then it's not less than 0 anymore. So our interval notation will be negative 3 because this is not equal sign to negative 2, right? Because we don't want to take 2 union. Oh, we don't want to take 2. So from negative 3 to 2 and union with 2 to 5. And here you go. That is the solution of polynomial inequality. And you see that the interval tell you everything. The interval that is the solution of this polynomial. It's not just negative 3 and 2, or it's not just negative 1 or 0, but all the value. It could be decimal, could be irrational, could be irrational, could be anything. Okay, could be anything. Of course, it's not complex because we're dealing with the number line, the real number line, so it's not complex one. Okay. Okay, so that is the second example. Let me see if I can give you something harder than this. So we're gonna go from the easy one, the standard one, then we go a little bit harder. Then let's go to another level. On the test, I'm gonna put everything in factor form, especially for inequality. Okay, I don't want you to factor. You know, for factoring, this is for so many polynomials. So for inequality, I'm gonna put everything in factor. So what if I have something like this? I have 4x minus 3 raised to the 5th times 2x times x minus 1 raised to the 3rd times it's going up, so okay, time x minus x plus pi square. Okay, let's do something fun, you know, and we want is less than or equal 0. Okay. So first of all, we need to analyze this. How many 0 we have here? If we set each of them equal to 0, we set for the x value, right? So on the number line, we have what? We have, so we're going to set each of them equal to 0. So 2x equal to 0, 4x minus 3 equal to 0, x minus 1 equal to 0, x plus pi equal to 0. You know, I kind of skip this step on the second example, because it's the second example you can see right away, and this is give you 0, and this is equal to x equal 3 over 4, this x equal 1, this is x equal negative pi. Alright, and you're going to put all of that on the number line. Okay, so you can have what? You can have 0 in the middle, right? You have 0 in the middle, and you have negative pi negative 3.14. So negative pi on this side. So you have 0 over here. You got 1 over here. Oh, you got 3 over 4 over here. 3 over 4 before 1. So you have 1 over here. You know, you don't have to divide the number line. You don't have to scale it. That's what I mean. Okay, as long as you put it in order, that would be great. Okay, so I put all 4 0 on the number line, and you see that it created 1 2 3 4 5 interval, right? For 5 interval, and we're gonna pick a value and you plug it in. You see that over here, so you plug the value over there. So for example, you plug 2 over here, so 2 2 2, all of them will be positive, right? Easily. You plug 2 over here, you plug 2 over here, positive raised to the 3rd power is positive, 2 plus 2 pi is positive raised to the square positive, everything is positive, okay? And you plug a value between 3 4 1, you will see that it is also negative, right? For example, you want to plug like 0.5. Okay, 0.5 you plug it in, this should be negative, and and this one you're gonna plug it in, you give you positive, and this one you plug it in, it give you oh, there's a very interesting thing here over here. So you plug it in over here, give you what is the between negative pi and 0, so you can plug a negative 1 in, so it should be a negative negative, right? And you plug in the value between negative infinity and negative pi. You can put negative 4. Okay, you plug in negative 4, so it should give you negative. Okay, I'm gonna do it really fast, but you go ahead and calculate for yourself. So you know, you gotta pay attention to you notice this value 0. When you plug 0 into that, the answer is 0, right? Everything you plug in is 0, the whole thing is 0, so it still satisfies inequality. So if you plug 0, it still satisfies inequality, so it's still 0. so which is good, and we want everything less than or equal to 0. So basically we want everything over here, we want everything over here because we would want this, and a 0 included because you plug 0 over here, it's still equal to 0, so it still works. So our final solution will be negative infinity. If you plug negative pi in, what happened? Negative pi, so it turned out to be 0, right? So negative pi turned out to be 0, so it still works. Okay, so negative pi turned out to be will be equal to 0. You look at that, negative pi plus pi 0, so it still equals 0, so it's work, right? So this value is work, so the 0 is between negative infinity and 0 should be okay. All right, so be careful over here. When you plug 1 into this, look at that. When you plug 1 into this, 1 minus 1 is 0. It's still less than or equal to 0, so you have to union with what? Union with 1, right? And union with what? 3 over 4. When you plug 3 over 4 over here, 3 over 4 cancel them out, so 3 minus 3 is 0, so it still equals 0. So 3 over 4 is still the solution, and your union with 1 is the solution. But you cannot plug the value between 1 and infinity, or negative 3, 4, and negative 3 over 4 infinity, because when you plug it up, first of all, you plug 2 over here, right? You plug 2 over here, 2 over 8, and it's positive, 2 over 1 is positive, everything is positive, so it does not satisfy this inequality sign. So something greater than 1 doesn't work, right? Something greater than 1 doesn't work. Yes. Something between negative 3 and 4 also doesn't work. Okay, and between 0, 3, and 4, it does not work either. Okay, so this will be the solution of this inequality. Okay, all right. So on the test, I'm going to give you something similar to this. I don't think I'm going to give you a hard one. Maybe I'm going to put in fraction, but I mean, fraction is the same, right? I mean, it's just nothing hard. Maybe I'm going to use the pi, use e, you know what e number is. So, I mean, I make it a little bit, I beautify it a little bit, but I mean, the concept will be the same. Okay. Now hold on, let me see. I think I got a mistake over here. Okay, so yeah, a little bit mistake with the interval bracket right here. So you plug 0 over here, 0, 2 times 0 is 0, so it's still satisfied. So I mean, this is a bracket, I'm sorry, it's a bracket. So 0, negative pi also work. Negative pi also work, right? Because negative pi over here is to be equal to 0. Okay, so I think I had a mistake over here. It should be negative infinity to pi bracket negative infinity to negative pi bracket, because negative pi still work. Look at that, negative pi plus pi 0 is still satisfied. Okay, union with it's a little bit wrong over here. Union with negative pi here and 0. Actually over here, because you already include negative pi, so you can put parentheses here, because we already include negative pi. Okay, let me rewrite. So final solution will be negative pi, negative infinity to negative pi bracket union with negative pi 0 bracket. Okay, union with 3 over 4 union with 1. Okay, every time you have one value, you're going to use the curve bracket. So what does it mean over here? It means that all the value between negative infinity and negative pi is it always make the function less than or equal to 0, including negative pi, because the negative pi you plug in is still equal to 0, because we already included, so you don't have to include it. You don't have to put a bracket over here. It doesn't make sense. Okay. And over here, between negative pi and 0, 0 must be bracket, because when you plug 0 over here, you see that still equal to 0. So 0 must be included there. Okay, so that's a little bit. So you have to check carefully. You have to check carefully. Okay, it's kind of very easy to get mistake, but I mean, you have to look carefully and see which one satisfies. All right. So I think that's all for the video today. This is a very long video for this section, so I'm gonna split it into I already split it into 2 parts, and for you, I mean, it takes a lot of time for me to pause it, so I have to split it into 2 parts. Okay, then next time in the next video we're gonna jump to section 5. We start with a new chapter, and in this chapter we talk about rational function. Actually, we learned some concept we already focus on college algebra, but we other than that we do some example that's more complicated than the example of a rational function we had in college algebra. Okay, so I'll see you the next time. Bye bye.